Hi, Lucy.
So we're looking at Hungarian algorithms today. So basically when it comes to Hungarian algorithms, they're what we call an assignment problem. An assignment problem is where we have, in this case, 4 different people we want to assign to 4 different strokes of swimming. Okay, so these students here, according to your information that you have in your sheet here, the teachers, the coach wants to put these 4 students into a medley, and they want to work out, well, who's going to take the best, who's going to take which stroke to get the optimal performance. So when it comes to Hungarian algorithms, what we're trying to find here is we're trying to find the optimal solution. And we can do this 2 ways. We can do it either, so there are 2 ways. We can either find the minimum or the maximum. Okay. However, why do you have to use Hungarian algorithms? Because Hungarian algorithms makes this task easier. So for instance, if we had a look at this table here, you may think, well, we could try and work out who would take which stroke. So for instance, we might say, well, Zach can have the freestyle because he does it in 27 seconds. We then look at the next one and we'll say, okay, well, Chris can't do freestyle, so his next fastest one will be butterfly. Then we have a look at the next one and go, well, the fastest one that Lenny could do was butterfly. We're now going to have to say he's going to have to do backstroke, which then means that Monty has to do breaststroke, which in this case here is Monty's second worst, it's third worst stroke. Yeah, okay? Our third worst stroke. Alright, so that's not going to be an option. So therefore we might turn around and say, well, let's scrap that and say, well, Monty's best one is here. Let's do that. So therefore, we then come along here and say, well, Chris can't do that. The best one Chris can do will be here. Which then wipes out the fact that Zach now has to do breaststroke, which he's the worst at for both of them. So we have a look and they go, well, he can do that in 33 seconds, he can do it in 38. Well, let's do it here. And again, Monty, who was it? So Chris would have to do, actually we'll switch it around. Chris would have to do this one. And Zach would have to do that. Oh, okay. So there's a lot of different ways that, actually, Chris can't do that because he's doing freestyle, isn't he?
Yeah.
It's Lenny has to do it. Okay, so that again, that's one of Lenny's worst strokes as well. We can go through this again and again and again and again, you'll be using a lot of energy and eventually you may get the correct one. What Hungarian algorithms allows us to do is it allows us to eliminate all of the possibilities that won't give you an answer. Okay?
And is the goal to get the fastest relay team?
Yes.
Okay.
Alright, so in this question here, it says to us, what stroke should each swimmer use to give the shortest relay time? So that means that's a minimum optimal solution question. Okay, so what we're going to do here is I'm going to write down the steps that we take and we're going to do the steps. I don't want you writing down as you go, I just want you to follow so you can see how it goes because it does get a little bit complicated as we go along. So we know that this first one is a minimum. So the first thing we do when we find our minimum is, step 1 is we subtract. Again, you don't have to write this down because I'm going to give it you in with written details. Subtract the smallest value from each row. Okay, so in this case here, in this case we're going to subtract, because what we're trying to do is we're trying to get as many zeros as possible. So let's subtract the smallest number from each row. So minus 27, minus 29, minus 30, and minus 28. Okay? So that means it takes us down. We get a new matrix, which comes down here. So we end up with 0, 6, 6, and 3. Yeah? Along here, we end up with 0, 7, 3, and 0, 2, 4, 3, and 0. And the last one will be 0, 9, 10, and 3. So what we've done here is, the more zeros that we can get, the better we're getting closer to our answer. Okay, so a 0 indicates that that could be an optimal solution. Yeah? So step 2 now is we then subtract the smallest value from each column. Okay. So in this case here, 0 is your smallest value, so we won't touch that one. -4 here, -3 here, and we won't do that one because 0 is your smallest column, because it's not going to change. But we'll put 0 there anyway, just so you can see that it does get used. Okay? So if we then,
Sorry, I don't understand. Oh, okay, yeah.
because 0 is the smallest one,
Yeah.
so there's no use me subtracting from it because
Yeah.
right, you can't get any negative values. So we then write our new answer over here, and that gives us 0, 0, 2, and 0. 2, 3, 0, 5.
And we don't have a calculator.
No calculator. Nope. 3, 0. That's not frightening you, is it?
No.
No?
Simple maths, I love.
So now we got to this point here. We've got a lot more zeros. We're going to do our first test. So the third one is your first, and it could be the only test you do. Okay, so what we do here is we want to okay, so we want to place horizontal or vertical lines through the zeros. A, if the lines match the order of the matrix, solve the minimum or maximum value. B, if okay, so this next one here, we've got two options. This is our first opportunity to get to a point where we can solve. If, when we start placing horizontal and vertical lines, only horizontal or vertical lines, you don't really know how to write this down. We're going to see if we can cover all those zeros of lines. If the lines match the order, so if I can get 4 lines through here, minimum number of lines, then I've got a position where I can then solve this.
What do you mean by that?
I'm going to do that